Hey everybody, the purpose of this lab is to understand the analysis section of the activity series lab from last week, and also to introduce the pre-lab assignment for the mass relationships lab that you'll be starting next class. If you could take a minute to get out the activity series lab, and also to get out the handout you just picked up on mass relationships. To the person covering my class, feel free to pause this video at any point if students need to get things out or get ready for something. The place we're going to start is the data table for the activity series lab, and unfortunately, in order to do this lab successfully, you need to have the right data. So, if your data does not match what I'm about to write, just make a little change. So you should have 3 reactions showing. First one is that one, and then this one, and then this one. If you had any other reactions, they weren't actually happening. So there's probably some contamination in that well, or some other issue. Maybe it looked like a reaction, but it really wasn't. Before we move on, there's one thing I want to point out. The diagonal column here can't have any reactions. And some of you probably realize this. That diagonal represents adding a metal to the same metallic ion, and so there's no reaction there. Alright, so that's part 1. Make sure that you have that data going forward, and then we'll talk about the analysis on the next page. Some of you have already completed this page. If you did, you had word equations on these lines, and it only involves switching the place of the metals. So for part B, for example, the products would be magnesium plus zinc nitrate. So it's important that you do all of them so that you can reference them later. The other thing you need to do is down here at the bottom of the page. It says for each combination that actually resulted in a chemical change, you need to translate that word equation into a chemical equation. So what you want to do is go back to your data table and try and find the 3 reactions that are then listed in the analysis section. So we're going to do this first one right here for magnesium and copper nitrate, and then we'll just figure it out from there. So magnesium and copper nitrate is that one, and you want to translate this into a balanced chemical equation. So hopefully you've got the word equation already written out, but you just want to use the formulas from the previous page to translate this into a chemical equation. So the products here are going to be copper and magnesium nitrate. And if you've done it correctly, you shouldn't need to balance the equation. So that's the other thing you're doing on this page, is just translating 3 word equations into chemical equations. The next thing I want to talk about is the final page of this lab, where it says you're actually creating an activity series. So that's questions 3, and we'll talk about 4 and then 6. The idea behind this section of the lab is that you're going to build yourself an activity series along the right-hand column of this page. Okay? We're really just going to follow this first rule here, but we want to make sure that we leave enough space also. So it says place the metal that reacted the most often at the top of the column and continue in that manner, ending with the metal that reacted least often at the bottom of the column. So if you take a look at your data table, and there's 3 metals listed along the left-hand side, the one that had the most reactions should have been magnesium. So near the top of your page, you want to list the symbol for magnesium. It reacted twice in this experiment. The metal that reacted only once is zinc, so you want to leave a little bit of space between magnesium and zinc, because we're going to be adding to this list later. So zinc goes underneath magnesium. And then the last bit here, the metal that reacted the least often was copper. It didn't react with anything that we used in this lab. So when all is said and done, you should have an activity series that has just 3 elements in it. So magnesium, then zinc, then copper. So it's a list. At the top of the list is going to be the most reactive metal, and at the bottom is going to be the least reactive. So in any random situation, magnesium will react more often than zinc or copper. That's one thing that this says. Okay. I'm going to leave it up to you to answer question 5, but in order to be able to answer question 5, question 4 has to make sense. What you want to do is take a look at these formulas. Oops. And write the formula for any metal that is written as an ion, which sounds like a strange question because you don't see any charges written there. But you have to figure out which formulas here show metals in an ion form. And the key to this is understanding that when you just see the symbol of an element, it's neutral. So magnesium can't be an ion because it's just a plain old element. That eliminates zinc also. What's left is copper nitrate, sodium nitrate, and aluminum nitrate. When a metal is in a compound, it is in the form of an ion. And so your job now is to write the formula of copper ion, sodium ion, and aluminum ion. So I'll do sodium because it's the easiest one, and then you can do copper and aluminum. Because of the formula NaNO3, and also sodium's location on the periodic table, I know that sodium has a charge of +1 when it's an ion. So you want to have your answer look like that, and you want to come up with the two other answers for copper and aluminum. Then you're going to answer question number 5 based on this answer, and then also based on your activity series. The last thing for this lab is that we're going to do right now is number 6. Based on your activity series and this new information right here, you're going to add in some more metals. So I'm going to do specifically nickel with you, and then you can kind of see, hopefully it'll give you a hint to number 5 also. So you're going to put the symbol for nickel, which is Ni, in the right location on this activity series. So it says when nickel metal is placed in each of the solutions used in this experiment, that would be magnesium nitrate, zinc nitrate, and copper nitrate, it reacts with the copper nitrate, but not with the magnesium and the zinc solutions. So what that means is the symbol for nickel has to go in between zinc and copper. It does react with the copper, but it doesn't react with the zinc or the magnesium. So in this activity series, it's got to go here. So using that information, you will need to answer question number 5, place all of the other metals in number 6 into the activity series, and then use the activity series to answer question 7. This lab for you is due next class, so just make sure you take some time during class today to get as much of this done as possible. Next up is the mass relationships lab, so take a minute to switch things around and get that mass relationships lab going. You'll also need your periodic table for this first part. Okay, so this lab, mass relationships and chemical changes, bridges the gap between our reactions unit right now and the unit that we're going to start after the test on Friday on chemical quantities. So this lab is going to take us 2 full days, I think, to complete. So in order to maximize time, I'm going to ask you to complete this pre-lab calculations section before you come in next class. So the deal with that is, if you come in tomorrow and you have your pre-lab calculations done correctly, then you will be allowed to do the lab starting next class, and you should have plenty of time to finish. If you do not have this assignment done when you come in tomorrow, you'll need to come in outside of class to finish the lab. I will not allow you to do the lab tomorrow if you do not have this assignment done. So you should be pretty much ready to go when you come into class. We are going to do the first one together, and then you will be pretty much on your own for the other 3. These are things that we did in the previous unit, so you should just maybe look up your notes for this stuff and do it with your lab partner. So the first calculation is going to be to actually write the reaction that we're going to perform in lab. The things you need to know is that calcium chloride and sodium carbonate are the 2 things that we are using. So we're going to write some formulas and predict some products. So calcium chloride and sodium carbonate, those are both ionic compounds. You need to use your periodic table to figure out the charge. And so you're just going to go one ion at a time before we even start to do this. So calcium, because of its location, is a 2+ ion. Chloride is a -1. Sodium is a +1, and carbonate is a polyatomic ion, CO3, with a -2 charge. So we will use only these charges to write the formulas. This reaction, because it's between two compounds, is going to be a double replacement reaction. So we'll go, again, one at a time through this and write the equation. Okay, so first up is calcium chloride. So calcium has a +2 charge, chloride has a -1 charge, so the formula should be CaCl2. Next up we have sodium carbonate. Sodium has a +1 charge, carbonate has a -2 charge, so it's going to be Na2CO3. So those are the reactants for this reaction. Okay, in a double replacement reaction, the two metals are going to switch places. So the calcium and the sodium are going to switch places to make our products. So that means that sodium is going to end up with chlorine. Sodium has a +1 charge, and chlorine has a -1 charge. So their charges are balanced, so the formula is NaCl. Calcium is therefore going to end up with carbonate. Calcium is a +2 ion, carbonate's a -2 ion, so their charges are all balanced. So CaCO3 is the formula for that. It does say do not balance this equation. It actually might not say that on your lab, so I'm just going to balance it just in case. And that kind of gets at our purpose here. Our purpose is to, with our lab data, rebuild this chemical equation and examine the quantities in it to see what's conserved or not. So we've talked about the law of conservation of mass that we are hoping to prove here, that the masses of these two reactants will equal the total mass of the two products. We're also going to investigate atoms, moles, and particles. So these are things that we will investigate to see if they are conserved. What you need to do for tomorrow is to do calculations 2, 3, and 4 on the front of this. So you'll see some things that we haven't done for a while, and you'll just need to look those things up. We did these, over and over again in the mole unit, and so you just need to remember how to do that. For numbers 3 and 4, it does say calculate the mass. And in this lab, you'll be obtaining that exact mass of each reactant in a beaker or in a flask tomorrow. What you want to keep in mind is that our balances in the lab only record to the hundredths place. So when you actually get your final answer, just round it to the hundredths place. So when you get to the balance, you can get that exact value. So once more, in questions 3 and 4, you're going to be determining the mass of the two reactants that you actually need to obtain in order to do this reaction. It is definitely not a bad idea to read through the procedure. You'll see that it's quite a lengthy procedure. The day 1 procedure is pretty intense. You'll be doing a lot of things in our first block for that. Day 2 is a lot lighter. It's going to take about the same amount of time, but there's fewer steps. So it is to your advantage to come in tomorrow, certainly with these calculations done, but also having read the procedure. So good luck with this, and I will be around for office hours tomorrow if you have any questions. Thanks.